right, here we go. Let's continue with this. We said this was 300 degrees. This should be 150, and it's also 150 for another reason. Look, if this is 30, then this angle 2 is a what? Give me a fancy geometry word. It's what to angle 2, or angle 1? Supplementary. It's supplementary, so that has to be 150. We could get 150 a couple ways, right? You could have just looked at this angle and said, okay, if this is 30, then this has to be 150. Or you could have said, all right, if this arc is 60, then this arc is 300, which makes this angle half of the arc. You get it? Okay, so you could get that kind of stuff different ways. That's the kind of stuff you need to be looking for. Look, we're getting more information and more information as we go with these circles and what arc is equal to what angle and stuff. So you got to keep them straight. You got to study them. You got to look over them from time to time. Okay? All right, let's move on. All right, now we have a situation. We talked about this earlier. We said this would happen, and now we're finally at the point where we're going to have two secants, but they intersect not inside the circle, they intersect outside the circle. So if you look at that right there, oops, that went red, I don't know why. Anyway, right here, they intersect outside the circle, right? And we'll call it an angle, I don't know, we'll just call it angle 1, I guess. I have no imagination for what to call these things. We'll just call it angle 1. Now, I want you to see this. This angle 1 cuts off two arcs as well, doesn't it? I'll tell you what, let's go the other end of the alphabet. See, now I'm being creative, aren't I? Alright, so watch what we have. Angle 1 cuts off what arc? This one right here and YZ. Alright, so it cuts off those two arcs right there. Now, when it intersected inside the circle, what did we do to those two arcs? Remember? Well, we divided by 2, but what did we do to the two arcs at first? We added them up. Remember I said that was the only time, girls, remember I said that's the only time where we're going to add them up? This time we're not adding up. What do you think we're going to do? We're going to subtract. That's right. So basically, it's kind of the same thing, except it's not addition, it's subtraction, right? Same thing, but different. You ever hear anybody say that? Well, if it's different, it's not the same thing, is it? All right. So, anyway, it's kind of the same thing, but it's different because you're going to subtract. So let's write down our little formula with these letters. So angle 1. Now, on subtraction, it definitely makes a difference which one goes first. If I said 3 minus 5 and 5 minus 3, is that the same exact number? No, it's not. Okay. So, what order do you think we're going to subtract these in? The highest minus the lowest. That's right. Okay, they take the biggest one, which is arc YZ, and subtract the smaller one from it. Okay, so YZ minus, so it's half though. Don't forget, all these have a half in it. All right, half of arc YZ minus, we take the bigger arc minus the smaller one. Notice the bigger one is the one that's furthest away. Do you see it? And the one that's closer is the smaller one. So the one that's furthest away, the bigger one, minus the smaller one. And that's WX, arc WX. And there you go. I don't know, let's just make something up. Let's say that was, I don't know, 50. It's probably not even close to 50. But let's say this is, I don't know, what was I calling me? 150? Yeah, okay, we'll say 150. That's good. Sorry. People calling me during school. All right. 150 and 50, that's good enough. So how do we find what angle 1 is equal to? This may not be to scale, but I don't care. The math still works. So angle 1 is equal to half. I like to do the subtraction first and then divide by 2, don't you? So I'm go what? 150. You can do this in your head, but I'm showing you. 150 minus 50, which is 100, divided by 2. So angle 1 is 50. Probably wasn't the best thing to do. It just happens to come out 50. That doesn't mean that every time this angle is going to be the same as this arc. Does that make sense? It just happened to in this situation. I probably should have picked a different thing. But you get the idea. All right? So you take this arc minus this arc. You take half of it. Don't forget to take half of it. And then you've got the angle. Okay? So that's the angle that's formed by those two secants outside the circle. This theorem, it's one theorem because it's the same exact equation, but there's 3 parts to this theorem. All right? This is the first part of the theorem, and it's what? What are these lines? They're what? 2 secants. That's right. So this is 2 secants. All right? The next 2 are going to be the same formula, the same idea, but it's not going to be 2 secants. And where does it intersect? It intersects outside the circle. This one up. Okay, now we have a different situation. Instead of two secants, we have now a tangent, which is this one, and we have a secant. So we have a tangent, I'll write it down, and we have a secant. And they both intersect outside the circle as well, okay? They're not intersecting on the circle like we did before, but they intersect outside the circle. Well, let's call this angle 2, all right? You still have, let's do a different color, I'm tired of that. Let's go blue. We still have two arcs that are being cut off, don't we? Look, we've got this arc right there until it hits there. And I'm going to do this in a different color so that we can see. We'll go pink, all right, or purple, whatever that is. And I'm trying to trace as close as I can to that circle, getting a little squiggly. That's not bad. It's not great, but it's not bad. All right, so look what we have. We've got these arcs. What are we going to call this? Let's go A, B, C, D again. Actually, we can just go... Yeah, I'm not sure that's more than 180. I can just put a D right there, couldn't I? All right, now check this out. See what we have. Angle 2. Remember what I said? This is the same theorem, so it's the same formula. It's the same exact math. All right, so angle 2 right here. Angle 2 is equal to half the difference of the two arcs. Which arc are we going to do here? Which one's going to go first? The big one, which is what? Name it. BD or DB, right? So arc BD minus which one? AB. You see that? Those are two arcs that are cut off by the tangent and the secant. It comes to here. That's kind of like a dividing line right there, isn't it? Okay, because the arc formed by those come to here and stop. The arc formed by this one up here comes down like this. All right, we got that? Again, it's pretty simple. We're not going to put any numbers in here. I mean, you can figure that out. It's the same exact situation. So when you have a secant and a tangent intersecting outside the circle, the angle is half the difference of the intercepted arcs. Wow, that was a mouthful, wasn't it? All right, but you can play it on YouTube and listen to it and see if that makes any sense. All right, let's go to one more. All right, now we have a situation where you have two tangents. So two tangents. And again, where are they intersecting? Outside the circle. That's why this is the same theorem. Even though it looks like three separate things, it's really not, is it? It's really the same thing because they still intersect outside the circle. They still have the same equation and all that kind of stuff. But again, the arcs just look a little bit different, with each of these. So let's go to this. Let's make it a little bit thicker. All right, and I'll try to outline it. So look at this arc that those two tangents cut off right there. And let's use another color. Let's use the green. And where's the other arc? Now this is the one that people don't see a lot. All right, do you see this arc that I'm tracing right now? A lot of people don't think about that arc, but it is being cut off, isn't it? Because look, the tangent hits at that spot right there. Okay, hits at that one point. So it's cutting off this arc here, and it's cutting off the arc right here. Do you see the two different arcs? Obviously. All right. So again, what did I say? It's going to be the same exact equation. So if we'll call this angle 3, and we'll call this A. We'll call this B, and now this is a major arc right here. So I'm going to give it another letter. Give me just a second. So watch. What's it going to be? Angle 3 is equal to half, good, of arc ACB, okay, minus what? Arc AB.
Jill Lovett.
Let me give you the homework.
Alexis Short, Kate Netzer, Will Gossett, Alex Feeney.
It's page
Ryan
732.
Barrett, please come to the office.
732, and you're doing 8 to
All
23.
varsity baseball, you are dismissed, and all varsity
Right there.
softball, you are dismissed.
732, 8 to 23. This is ACB minus AB. Okay, it's those two arcs right there.